When we're talking about a series, we're adding up the terms of a sequence. Well, when we add up, you can think of something called the sigma notation. Sigma notation means the sum of. If I have a sigma notation of u to the I, that's a subscript, I equals 1 to the n, that simply means we're going to plug in 1, and then add, and then plug in 2, and then the sigma says add, plus plug in 3, and add, all the way till we get n. If we said n is 5, then we go u1 plus u2 plus u3 plus u4 plus u5. If n was 26, we'd go u1 all the way plus to u26. The sigma notation just says, take the sum of, or add. With the sigma notation, which just means the sum of, we've got three important properties. The first one is that the sigma is distributive. In other words, if I equals 1 to the n of two functions, ui plus vi, or they may represent some other things as well, then we can distribute this out. It's going to be the sigma of ui plus the sigma of the vi. And again, we're going from I equals 1 to the n and I equals 1 to the n. So we can distribute with this sigma. Our second property should be no surprise for you, those of you who have been paying close attention all through the course. If we have sigma notation from I equals 1 to the n of some constant k times ui, we can pull this constant out in front and multiply it by our sigma notation. So this becomes k times sigma I equals 1 to n of u to the I. We can pull that k out in front. That's just a constant. Our third property is that if we take the sigma notation of a constant n times from I equals 1 to the n of some constant k, our answer will be k times n. For example, if you take I equals 1 to n is 5 of a constant 3, well, that's just adding 3, 1, 2, 3, 4, 5 times, which is the equivalent of just multiplying 3 times 5, as you see there. So if you're taking the sum of some constant, you just have to multiply the constant by the number of times you want to take the sum of that constant. Here we have our first problem involving sigma notation. If u subscript I equals 5 plus 2 subscript I, and v subscript I is equal to 2 minus 5 subscript I, what is the sigma of 1 to 5 of ui? Well, we know that that's 1 to 5 of ui is 5 plus 2i, and we know that this can be distributive. We learned that one of the properties of the sigma is that it's distributive. So I can write this as 5 plus 2i and split it up into two different sigmas. Well, what is the sigma of 5 with a top n of 5? It's simply going to be 5 times 5 because this is a constant. That's where I get 5 times 5. Well, here I have to plug in 1, then 2, then 3, then 4, all the way up to 5. So I plugged in 1, 2, 3, 4, and 5, and I multiplied by the 2. This sum is 30, plus the 25 gives you 55. Here's another example of the sigma notation. If I have the same ui and vi, and I'm asked to find the sigma, the sum from 1 to 5 of 2 ui minus vi, I can immediately replace ui and vi with what they are equal to. That's our first step. Well, then I can separate them apart because of the distributive property and take the constant k, which in this case is 2, out. So I move the 2 out here, and I separate these apart. I actually take out a negative 1 here too. So my k in this case is negative 1. I move that out in front. My k in this case is 2. I move that out front. And I've done the distributive property as well of my sigma. Now it's just a matter of plugging in 1, then 2, then 3, then 4, then 5. And when I do that, I get 2 times 7 plus 9 plus 11 plus 13 plus 15. And also, this minus comes down here, and I have to substitute in 1, then 2, then 3, then 4, then 5. And when I do that, these sums become negative 8, negative 3, negative 8, negative 13, negative 18, negative 23. Get the sum there, multiply by 2, and subtract, as you see here, and you'll get 175. Here's another problem with sigma notation. Again, our ui is 5 plus 2i, and vi is 2 minus 5i. And we're asked to sum from 1 to 1,000, 5 ui plus 2 vi. Well, we know, of course, that we could distribute, and we can move constants out in front, and we can take the sum of a constant by multiplying this by the top number there. Well, this is a new way to look at it. Well, first thing, we substitute for ui and we substitute for vi. But instead of separating them out, pulling the constants out in front, what we do is we distribute, and we keep it as one sigma. Distribute 5 times 5, 5 times 2i, 2 times 2, 2 times negative 5i. And you see here that 10i and negative 10i cancel, and we're left with I to 1000 of 29, which we know is simply 29 times 1000, which gives us 29,000.